Okay. Now, today we are going to learn a new topic by the name of virtual work. Now, before we start with the concept of virtual work, we must understand, or we must rather clarify our existing concept of work. So let us start with the work done by a force. Work done by a force, as you can see, is the dot product of force and displacement. Now, what is the meaning of dot product? Let us understand this. Let us say I have a block of mass m resting on a surface, and this is a completely smooth surface. There is no friction. So that means if I pull or push the block of mass with even the slightest amount of force, the block will easily slide and there will be no resistance offered in the backward direction to motion. Now let us say I am pulling it with a force of 2 Newton, which is inclined at an angle of, let us say, 30 degrees. Now I want anybody among you who's confident enough to tell me what is the total amount of work done by the force here. For example, let us say by the application of this 2 Newton at an inclination of 30 degrees, this mass moved in the forward direction by, let us say, 2 meters. So tell me what is the amount of work done by the force of 2 Newton on this mass m when the mass has moved forward by 2 meters. What is,
Sir, two root three
how did
joule.
you arrive at the value of 2 root 3?
So the formula is F dot D cos theta.
Okay, the formula for work done is F
F D theta.
cos theta into distance. Okay, F is 2 Newton, theta is 30 degrees. So that means 2 newtons multiplied by cos of 30, and that multiplied by the distance, that is 2 meters. So this eventually comes out to be 2 cos 30 multiplied by 2. And what is the unit of work done? Unit,
Joule.
Sir, Joule.
the unit of work done can either be written as Newton meter, which, if you recall, is also the unit of moment. Moment is force multiplied by distance, right? The unit of moment is also Newton meter. The unit of work can also be written as Newton meter, or rather, the definition of work itself goes by the concept of a single Newton force acting on a body and engaging it through a distance of 1 meter. And if I put it very simply, एक बार अगर हिंदी में इसको समझाऊं तो एक न्यूटन की फोर्स अगर किसी वस्तु पे लग रही है और अगर उसके प्रभाव से अगर वो वस्तु 1 मीटर चल पड़ती है तो कितना वर्क किया एक न्यूटन फोर्स ने 1 न्यूटन मीटर का वर्क किया. Now, when we talk specifically about work and not about a moment, then we can simply write 1 Newton meter as equal to 1 joule. So this is another famous SI unit that you have to remember. 1 Newton meter of work or 1 Newton meter of energy. Energy is also equal to work in terms of units. So the unit of energy, which we generally call as joule, is nothing but 1 Newton meter. So this you have to remember now. And the abbreviation for joule is simply capital J. So instead of 1 Newton meter, you can write as 1 J. This is the concept of work. Now, why did you have to take a product of cos 30 here? See, the definition of work is force into distance. For example, if I redraw the image like this, let us say the block is here, frictionless surface is here. If I apply 2 Newton force purely horizontally and it travels through a distance of 2 meters, then force is equal to 2 Newton, distance is equal to 2 meters, and therefore the work done would be simply put as force into distance. That is 4 Newton meter or 4 joule. This is the work done. But instead of taking a straight force, if I take an inclined force, then I had to take a factor of cos 30 degree also. So in this case, the distance is again 2 Newton. The same force is applied, but instead of being applied in the horizontal direction, it is applied at an angle of 30 degrees. Okay. So the force acting in the direction of displacement is 2 cos 30. And now this force will be multiplied with this displacement. So every time you have to calculate the amount of work done on any object, you simply remember one concept. The force and the displacement have to act along the same line. And until and unless they are acting on the same line, you cannot multiply the force and the displacement. So if 2 Newton is acting at an angle of 30 degree, the component of 2 Newton that is acting along the line of action of the displacement is 2 cos 30. And therefore the work done will be 2 cos 30 multiplied by 2 joules. Now there is another component of this 2 Newton. You know that. This is 2 sin 30. What will happen to this force? This force is also there, but the displacement is not acting along the vertical direction. So in other words, I can simply say that this component of force, which is perpendicular to the displacement, will produce no work. तो भले ही आप इस पे बल तो लगा रहे हो वर्टिकल डायरेक्शन में, लेकिन इस वर्टिकल डायरेक्शन के बल का कोई भी वर्क नहीं निकलेगा. There will be no work done for this vertical force, and that is the reason some conceptual questions in Viva exams are asked of the students कि एक आदमी 1 घंटे तक एक दीवार को धक्का लगा रहा है. दीवार means it's a vertical wall and the wall is not moving anywhere. Is the person spending energy or not? The question is, 1 घंटे तक एक आदमी एक दीवार को अपनी पूरी ताकत लगा के धक्का लगा रहा है, उसको पसीना भी आ रहा है, माइंड इट, ही इज स्वेटिंग. Is he spending energy or not? What will be your answer? I'm not talking about work. I'm simply asking you whether the person is expending energy from his body or not. What is your answer? Anybody? खाली दीवार को धक्का लगाया जा रहा है. There is a person who's pushing the wall, applying force on a vertical wall. The wall is not moving. He spends 1 hour sweating and pushing, but the wall does not move. Did he spend energy from his body or not? Can anybody give a response to this? Anybody?
Yes, sir.
Is he spending energy?
Yes, sir.
Yes, the answer is he is spending energy. Is he doing any work?
No, sir.
Work
The
done
displacement
is
displacement
zero.
is not happening.
Yes, absolutely right answer. Since the person spends 1 hour applying force on an object which is not moving, the work done will be zero. So until and unless displacement is produced, there is no utility in spending any energy. So energy spent is there. The person has definitely spent energy. Now, if the work is zero, where did all this energy go? This energy went in increasing the temperature of the body of the human who is pushing the wall himself. तो इनकी जो पूरी श्रम थी, जो पूरी शक्ति और पूरी एनर्जी थी, that was spent not in doing any work but in increasing his own body temperature, and that is why he starts to sweat. बॉडी का टेम्परेचर बढ़ता है तो बायोलॉजिकल मैकेनिज्म ऑफ द बॉडी किक्स इन एंड इट ट्राइज टू कूल डाउन द बॉडी, एंड दैट इज व्हाई यू स्टार्ट स्वेटिंग. पसीना इसीलिए आता है. So this is the concept of work done. Until and unless there is a displacement in the direction of force applied, there will be no work. Now let us check your concepts of force and work in another scenario. There is a person, a daredevil, rather we should say, who goes in front of a car and tries to push the car. The car is moving in this direction. This person is wearing roller skates. The person is applying a force of F Newton by pushing the car in the reverse direction. But as already told by me, the car is moving in this direction. And now, what is going to happen? Everybody knows that the person, being a simple person, would not be able to push the car in the backward direction. When the car itself is on, the ignition is on, and the car is moving opposite to the person. Now, what will happen? The person himself would be pushed by the car in the opposite direction. But now, my question is, if the car moves in this direction by, let us say, 3 meters, and the force applied by the person in this direction is, let us say, 2 Newton. Now my question is, what is the work done by the human on the car when he applies 2 Newton force and the human himself moves backward in the direction by 3 meters? What is the work done now? How many
Min-
joules?
So negative
minus
work done.
6 Newton meter, sir.
In this case, the work done will be minus 3 into 2 joules. Now this negative sign would have to be taken. Why did this negative factor come in? The negative sign comes in because the force is in this direction. The force is in this direction and the displacement is opposite to it. So you cannot say that there will be no work done. Definitely work done will be there because force and displacement have parallel lines
Parallel.
of action. So work done will definitely be there. But if the direction of force and displacement are opposite to each other, in that case, the sense or the sign of work done is taken as negative.
Negative.
Or in other words, you can say that the force did not do any work. Something else did work on the force. या फिर अपन ऐसा कहेंगे कि आदमी तो कार को धक्का लगा रहा था लेकिन आदमी खुद पीछे जा रहा है, कार पीछे नहीं जा रही. तो वर्क किसने किया? आदमी ने किया कि कार ने वर्क किया? इस केस में एक्चुअली वर्क कार ने किया है. किस पे किया है? आदमी
आदमी
पे
पे.
किया. तो इसीलिए हम ये कहेंगे कि द वर्क डन is by the car and not by the human. But
Human.
but if the question asked of you is what is the work done by the human, in that case your answer should be it is minus 6 joules done by the man, or in reverse you can say it is plus 6 done by the car. तो कार ने 6 जूल पॉजिटिव वर्क किया और आदमी ने 6 जूल माइनस में वर्क किया. दिस इज व्हाट यू हैव टू से. Okay.
Okay,
Now
sir.
this concept of work is clear now. So we can say that in general, if a vector of force is there and a vector of displacement is there, so I will put a vector symbol on these. Okay. A vector of force and a vector of displacement. And these two have an angle included of theta. Then the work done is defined as the dot product of the force and the displacement vector. This is the
Yes, sir.
actual definition of work. And the dot product in itself, when expanded, gives you the formula. You take the magnitude of force, multiply it with the magnitude of displacement, and put in the factor of theta. Now, if this theta is acute, then obviously the work done will come out as positive. And if this theta is obtuse, for example, force is like this and displacement is like this is your force vector, this is your displacement vector, and this is an obtuse angle theta. In this case, this product, the dot product, will come out as negative.
Negative.
So this concept of force and displacement and work done, I think, was already clear to you. But we
Yes, sir.
have taken some time and brushed up our previous knowledge of work, force, and displacement. And now, from the point of view of mechanics, to learn something new. Okay, before we proceed to that, you should also have a concept and knowledge of work done by a moment or couple. Let us understand that too. Let us say I have a disk and it is connected to a spindle, which in turn is attached to ball bearings inside the ball. Now, you come and apply a moment of, let us say, 2 Newton meter. Moment will have a unit of Newton meter. So in this case, you are applying a rotary effort. This is the direction of moment or couple that you have applied, and the moment that you applied was 2 Newton meter. And by doing so, this heavy wheel happened to rotate by a distance of theta in the direction of your applied moment. What will be the work done? The work done will be the moment multiplied by the angular displacement theta. So you have to remember both the concepts. In linear mechanics, we call it as linear mechanics. Work done is force into distance. In rotary mechanics, work done is moment into angular displacement. See, this is always going to replace force. Whenever linear mechanics is replaced by rotary mechanics, moment is always going to replace force. And the linear displacement will always be replaced by angular displacement. Or in short, what we write it as theta, phi, alpha, gamma. These are the symbols that we use for rotary displacement or angular displacement. So it's as simple as that. Now, again, in this example, suppose the disk was already rotating under the influence of some motor. Let us say there was a motor already fixed on the other end of the wall. There is a motor here which is running, and the disk is already rotating in the clockwise direction. And you apply a force or a moment, let us say, in the counterclockwise direction of 2 Newton meter. What will be the work done by the moment applied by you when the motor has already caused the wheel to rotate in the clockwise or opposite direction by an angle theta? In this case, the work done will be minus of moment into theta. The same concept of reversal of direction or the reversal of the direction of moment. If the moment's direction and the displacement, angular displacement direction are opposite to each other, then the work done has to be taken as negative. It should not be taken as positive. So the concept of plus work or minus work is as simple as that. And I would advise you to not fall in the trap of many textbooks that give you another concept of work, because it is going to create a lot of imbalance in the learning methodology. I'll tell you what is the trap of the books and how you can easily fall prey to the wrong practices. Is this a positive vector or a negative vector? Anybody?
Positive.
It's a positive vector because it is drawn towards the right side of the x-axis. If this is positive, then by definition this becomes a negative vector. And judging by the location of origin and the coordinate axis that I have chosen, this again is a positive vector and this is a negative vector. This is the actual sign convention that we use for all problems in mechanics. Now, let us take the same coordinate system and let us take a small problem. I am applying, there is an object lying on the floor. I am applying a force of 2 Newton and the object is actually moving in the opposite direction due to some already existing force which is not being discussed here. Let us say the distance is 2 meter in the opposite direction. So 2 Newton force is applied in the positive sense. The displacement is in the negative sense. What is the work done? Obviously, you would say plus 2 Newton because this is a positive force multiplied by minus 2 meter, which is the displacement in the negative sense. So the work done would be minus 4 Newton meter. There is nothing wrong with this, but it is not the right way to remember. Whenever you are calculating the sense or the direction or whether the work done is positive or negative, you always have to judge it by whether the applied force and the displacement produced are opposite to each other or not, and that should be the end of story. If the vector is here, this is the force, and the displacement is also in the negative direction, the work will be positive. Okay, if the force and displacement both are in the positive forward direction, again the work will be positive. Similarly for vertical direction, if the force is vertically upwards, displacement is vertically downwards, you don't go by checking the actual sense whether the force is positive or negative, whether the displacement is positive or negative. No, don't go for that. You simply just go and check whether force and displacement are opposite to each other or not. That is the end of story. So this will be negative work because they are opposite to each other. It does not matter whether force is downward or displacement is downward, whether one of them is upward, one of them is downward, it doesn't matter. They are opposite to each other. That is all that matters. And going by that concept, force in the positive direction, displacement in the negative direction. Forget about the individuality of sense of force and displacement, whether individually they are positive or negative. No, don't go by that. Simply see whether they are opposite to each other or not. Therefore, the work will be negative. So now randomly tell me, this is displacement, this is force. Work is positive or negative?
Negative, sir.
It's negative. You don't have to judge the direction individually for force and displacement. You just have to see whether they are opposite to each other or not. In that case, it will be negative. In all the other cases, it will be positive. Okay. Now, you have understood the concept of work in rotary mechanics also. You have understood the concept of positive work, negative work also. And now let us move on to the actual topic of your engineering mechanics, which goes by the name of virtual work. Okay, now before we start the concept of virtual work, first of all tell me how many of you know the English meaning of the word virtual? वर्चुअल का मीनिंग क्या है? किसी को हल्का सा भी आइडिया?
So the thing which is not real.
यस, एब्सोल्युटली.
Imaginary.
वर्चुअल मीन्स इमेजिनरी. वर्चुअल रियलिटी सुना होगा. वर्चुअल रियलिटी मतलब जो कि रियलिटी का आभास देता है. इट जस्ट गिव्स यू an imaginative experience of the actual reality. It is not the reality itself. So virtual work का मतलब भी यही होना चाहिए. It should mean the work which is not actually happening, but you imagine that some amount of work has been done. Now what is the use of such a concept? भाई आप तो किसी चीज को थोड़ा सा हिला दो ना तो चल जाएगा, तो एक्चुअल वर्क हो जाएगा. Why do you need the concept of virtual work? The concept of virtual work actually is very useful in solving the problems of engineering statics, which is a part of engineering mechanics. We will come to that. इसकी पूरी methodology आपको सिखाएंगे. But let us understand what is virtual work. Again, I will take a small body which is resting on the floor. I am applying a force on it, but the block is not moving. The block is in equilibrium. Why is it in equilibrium? Because obviously there is friction on the floor. If the floor was frictionless, then even by the smallest amount of forward applied force, the body would have moved in the forward direction. But since it is not moving in the forward direction, even though you are applying a force of F, so that means in this case, there must be some opposing force in the opposite direction. And now let us say the vertical reaction given by the floor on the block is capital R, and the coefficient of friction between the surface and the block is given as mu. Can you tell me what will be the value of the frictional resistance experienced by the block? What is the value of friction? These are the given parameters. Capital F is the actually forward applied force which is applied by you. Capital R is the vertical reaction applied by the ground on the block. Mu is the constant value of coefficient of friction between surface and block. इतना तो फ्रिक्शन आपने पढ़ा होगा, 9th क्लास में पढ़ा देते हैं तो. So tell me what is the value of frictional force acting in the opposite direction? It's mu into normal reaction. भूल गए क्या ये सब चीजें? You have to remember this. Frictional force is mu into R. Now, F is the force applied by you in the forward direction. Mu into R is the frictional force applied by the ground in the opposite direction. And if under the influence of this F and this mu R, this block is not moving, can I confidently say that the block is in equilibrium? The block is not moving, it's just standing there. Although there is a frictional force opposite in the opposite direction, there is a force F applied by you. आप खींच रहे हो इस block को, लेकिन फिर भी नहीं चल रही है. So that means the block must be in equilibrium. And under the action of forces, of multiple forces, if the block is in equilibrium, that must mean that the summation of all forces in the horizontal direction must be equal to 0. Or in other words, we can say that the positive force in the positive x direction plus the negative force in the opposite direction, when they are added, this is the meaning of summation. this must come out to be equal to 0. Okay, this is the meaning of static equilibrium. Now, let us bring in the concept of virtual work. What does virtual work say? Virtual work says that you assume an imaginary displacement. भाई imaginary work produce करना है तो imaginary displacement भी produce करना पड़ेगा. Force तो imaginary नहीं हो सकती. Force has to be something real. ठीक है? Displacements can be imaginary. Now let us see. This block is taken. You are applying a force F. Friction is acting in the opposite direction. Now, for some reason, let us say you want to find out the value of virtual work. Okay, you guys don't know what is the utility of virtual work. That we will come to that later. But I'm just telling you how to calculate or how to create virtual work. Virtual work को कैसे create करें? भाई जो ऑब्जेक्ट मूव ही नहीं हो रहा वो तो वर्क कर ही नहीं सकता. सीधी सी बात है. That is obvious 100%. We have already understood that in today's lecture. If it is not moving, there is no work. But what I want to do is I want to calculate something called as virtual work. So what I will do is I will imagine that the box has slightly moved towards the right direction. By how much distance? Let us say a very small distance, delta x. Now, did the box actually move in the right direction? No, it did not move. Then what is this delta x? This is what I call as the virtual displacement. Virtual displacement is an imaginary displacement given to a body which is in equilibrium. ये याद रखना है आपको. तो जो इक्विलिब्रियम में है, जो मूव नहीं कर रही, उसको आप जानबूझ करके किसी एक पर्टिकुलर डायरेक्शन में अज्यूम कर लेते हो कि वो चल पड़ा और थोड़ा सा चला, बस डेल्टा एक्स से चला. नाउ टेल मी व्हाट इज द वर्चुअल वर्क. Since the displacement is virtual, it's imaginary, so that means if any amount of work is generated by this displacement, that work will be called as virtual work. तो अगर आपसे कोई पूछे कि वर्चुअल वर्क क्या है तो इसका सिंपल सा सरल सा उत्तर यही है. वर्चुअल वर्क वो वर्क है जो कि वर्चुअल डिस्प्लेसमेंट देने के कारण प्रोड्यूस हुआ है. बस बात ही खत्म. सो व्हाट इज वर्चुअल वर्क? द डेफिनेशन ऑफ वर्चुअल वर्क इज इट इज एन इमेजिनरी और वर्चुअल वर्क which is created or produced then an object which is already in equilibrium is given an imaginary or virtual displacement. बस इतनी सी बात पे कहानी स्टार्ट हुई और यहीं पे कहानी खत्म हो गई. दिस इज वर्चुअल वर्क. तो आप बोलोगे यार ये तो बड़ा बोगस सा कॉन्सेप्ट है. यस, इट डजंट मेक एनी सेंस. आप एक इमेजिनरी डिस्प्लेसमेंट प्रोड्यूस कर रहे हो, फिर इमेजिनरी वर्क बोल रहे हो. व्हाट इज द यूज ऑफ दिस? We will understand the complete utility and the beauty of the concept of virtual work when we actually start getting answers of real life problems by the application of virtual work. Anyway, from this problem, I want you to tell me two answers. What is the virtual work done by force F and what is the virtual work done by force mu R? Give me the correct answers of virtual works with the proper sign. What is the virtual work done by force F?
Sir, it is F dot delta x Newton meter
F into delta x, plus or minus?
plus.
It is plus. Why plus? Because delta x is also in the right side direction and F is also in the right side direction. What is the virtual work done by the force of friction?
So minus mu r dot delta x.
So this is the correct answer. So this is virtual work of friction. And this is virtual work of force F. This is positive because force and displacement are in the same direction. This is negative because friction and displacement are in the opposite direction. So this is the concept of virtual work. Now, in order to use the concept of virtual work, we use another term that is called as the principle of virtual work. Now let us understand what does the principle of virtual work. In order to understand principle of virtual work, let us take an object. Now in this case, I am not taking an actual object. I am selecting just a small point as an object. Okay, there is a particle in space and some forces are acting on it. Let us say F1, F2, F3. And since these are vectors in space, I am drawing the vector heads over them. So what is the situation here? We have a body in the shape of a particle and it is being acted upon by three forces, F1, F2 and F3, and the particle is in equilibrium. So the situation is this particle is not moving, it is in equilibrium. Still, there are three external forces acting on it. So that means this relationship must be true. Which relationship? The vector sum of F1 plus F2 plus F3 must be equal to 0. Why? First of all, I can say that if some n number of forces are acting on a system, then the vector sum of those forces must represent the resultant of the forces. And if the object under the influence of these forces is in equilibrium, that directly means that the resultant of forces must be equal to 0. Okay. Now what does the virtual work principle say? The principle of virtual work says that if a body is in equilibrium, so the first thing that the principle of virtual work says is the body must be in equilibrium. That is the primary condition. But even though it is in equilibrium, there are some forces acting on it. So F1, F2, F3, I have taken randomly some forces and these forces are acting on it, but despite these three forces acting on it, the body is in equilibrium. So that means the straightforward conclusion is that the sum of the vector forces or the resultant must be equal to 0. That is why the body is in equilibrium. And now the concept of virtual work comes in. You give a small imaginary displacement to this particle. Let us say the displacement given is delta r in this direction. So delta r is also a vector. It is a displacement vector. So this particle has moved, right? So now the particle is here. What happens to the forces that were acting on the particle? They will also move. So F3 has a new location here. F2 has a new location here and F1 has a new location here. I hope this concept is clear. What we did is this point was experiencing three forces. You gave it a small displacement delta r. So whatever forces were acting on the particle, they also moved along with the particle. They were acting in the same direction, but you simply moved the particle, therefore the forces also moved, but they remain parallel to the orientations they were originally acting in. Now, what happens here is, now you try to calculate the virtual work of all the forces which were acting on the particle. F1 was acting at the particle at this point, but now F1 is acting at this point. So that means the point of application of F1 has moved. So what is the work done by F1? The work done by F1 can be simply written as the dot product of F1 and delta R. Similarly, the point of application of F2 has also moved. F2 was acting here, but now it is acting here. So if the point of application of the force moves, that means the force itself has moved. And if the motion of force is produced, then there is work done by the force. So the work done by the force, if you do not want to bother about the direction and all, you can simply put it as F2 vector with a dot product of delta R. Again, the work done by force 3 would be F3 vector dot product of delta R. So these are the individual works done by the individual three forces which themselves are in equilibrium with each other. Now, if somebody asks you what is the total amount of work by all the forces which was produced when this point was moved from this point to this second point, in that case you simply have to add the work. वर्क तो सीधे सीधे ऐड हो जाता है, जूल्स है भाई. F1 डॉट डेल्टा आर जूल्स पहले फोर्स ने काम किया, F2 डॉट डेल्टा आर दूसरे फोर्स ने काम किया और F3 डॉट डेल्टा आर तीसरे ने काम किया. टोटल वर्क कितना हुआ, ऐड कर दो सबको, दैट्स इट. Now in order to add them up, we make use of the algebra of dot products, or rather we manipulate or take advantage of the algebra of dot products, and I can simply write them as F1 vector plus F2 vector plus F3 vector. I take it as common, and the dot product with delta R. I can do this because it follows the commutative law. तो commutative law को यूज करते हुए मैं डॉट प्रोडक्ट के अंदर से F1 F2 F3 को कॉमन निकाल लेता हूँ, डेल्टा आर को कॉमन निकाल के बाहर रख दिया और इन सब के साथ में एक कॉमन डॉट प्रोडक्ट लगा दिया. Now what is the resultant of F1 plus F2 plus F3? This is the resultant R, and as we know, the resultant R is already equal to 0. Why? Because the body was declared initially to be in equilibrium. So if the body is in equilibrium, resultant will always be equal to R. So that means the total amount of work done, which now is given by R into delta R, must be equal to 0. So this, what you have seen here, is nothing but the simple mathematical derivation of what you call as the principle of virtual work. Now let us come to a standard definition of principle of virtual work. In your notes, I have already given you the definition of principle of virtual work here. But now you have seen the demonstration of the principle of virtual work, and I will give you a very simple definition of principle of virtual work, which you can either remember from the concept I have written in your notes, or you can remember from what you have understood over here. तो अब देखो, मैं एक बार पहले हिंदी में बात करता हूँ, उसके बाद आई विल गिव यू अ डेफिनेशन इन इंग्लिश. ठीक है? अगर कोई ऑब्जेक्ट इक्विलिब्रियम में है अंडर द एक्शन ऑफ अ सर्टेन नंबर ऑफ फोर्सेस F1 F2 F3 F4, तीन होना जरूरी नहीं है, कितने भी हो सकते हैं. तो वापस से रिपीट कर रहा हूं, एक ऑब्जेक्ट इक्विलिब्रियम में है जब ऑलरेडी उस पे कुछ F1 F2 F3 फोर्सेस एक्ट कर रही हैं, और अगर उस ऑब्जेक्ट को एक वर्चुअल डिस्प्लेसमेंट दे करके मैं सारे फोर्सेस का वर्चुअल वर्क क्रिएट करता हूं, तो जो टोटल वर्चुअल वर्क होगा वो हमेशा 0 ही होगा. दिस इज द सिंपल कॉन्सेप्ट ऑफ प्रिंसिपल ऑफ वर्चुअल वर्क. और अब इस प्रिंसिपल को अपन अपनी मैकेनिक्स की गणित में अपने फायदे में उतारेंगे, या फिर we will make use of this principle of virtual work for our advantage in solving problems of mechanics. तो अब ये प्रिंसिपल क्या कहती है? Once again, very shortly and sweetly putting the principle of virtual work in English language: if under the influence of some n number of forces F1 F2 F3 F4 Fn, an object is in equilibrium and a small virtual displacement is given to the object, then the sum total of virtual works of the individual forces of the system will sum up to 0. That is 100% sure. This is the principle of वर्चुअल वर्क। ये चीज समझ में आ गई क्या आप लोगों को? Somebody please put on the microphone who was paying attention. Anybody who is paying attention and tell me whether you have
Yes,
understood the
sir.
concept. समझ में आ गया?
Yes, yes, sir.
Okay. Now let us move on and let us see how we can actually make use of this principle. अब अपन इसको कैसे मैथमेटिक्स में फायदे में उतार सकते हैं ये देखते हैं। प्रिंसिपल ऑफ वर्चुअल वर्क हो गया, लेकिन उस पे अपन बाद में पहुंचेंगे। बट बिफोर दैट वी हैव टू कवर सम स्मॉल टॉपिक्स दैट आर गिवन इन योर सिलेबस। आपने प्रिंसिपल ऑफ वर्चुअल वर्क आज सीख लिया है। इससे पहले कि अपन कोई मैथमेटिकल एग्जांपल देखें, देयर इज समथिंग that you have to learn which is called as active forces and active force diagram। ये क्या चीज है पहले इसको देखते हैं एक बार। Let me first give you a definition of active forces। एक्टिव फोर्स किसको कहते हैं? Active forces are those forces which can produce virtual work। बस इतनी सी डेफिनेशन है इसकी। तो क्या है एक्टिव फोर्स? एक्टिव फोर्स वो फोर्स है जो कि वर्चुअल वर्क कर सकता है, खत्म बात। नाउ लेट मी गिव यू एन एग्जांपल। अब आप ये सोचोगे कि यार ऐसी कौन सी फोर्स है जो कि वर्चुअल वर्क नहीं कर सकती? भाई आपने पहले भी बोल दिया कि एक इमेजिनरी डिस्प्लेसमेंट देनी है। इमेजिनरी डिस्प्लेसमेंट दे दो, किसी भी फोर्स का वर्चुअल वर्क बन जाएगा, क्या दिक्कत है? लेट अस टेक एन एग्जांपल। The simplest example is created for these scenarios by taking a box resting on a floor। इससे बढ़िया और सिंपल एग्जांपल और कुछ है ही नहीं। एक्टिव फोर्स को समझते हैं। सबसे पहले एक फोर्स लगाई आपने इस पे F। इस बॉक्स का मास है M। Now instead of explaining the concept of active force and active force diagram, first of all let me see whether the concept of free body diagram is understood by you perfectly or not। तो अब मेरा क्वेश्चन ये है, एक्टिव फोर्स मैं आपको बाद में समझाऊंगा, पहले ये देखें कि इसका फ्री बॉडी डायग्राम कितने जने परफेक्टली बना सकते हैं। ठीक है, तो अब मैं ये कुछ नहीं कह रहा ये इक्विलिब्रियम में है नहीं है। ये हो सकता है मूव कर रहा हो सकता है खड़ा हो सकता है कुछ एक्सेलरेट भी कर रहा हो सकता है कांस्टेंट वेलोसिटी से चल रहा और हो भी सकता है कि ये इक्विलिब्रियम में भी हो। आई एम नॉट स्पेसिफाइंग एनीथिंग। I am simply giving you a scenario that a box of mass m is being pulled in the forward direction with a force F। तो अगर F की जो वैल्यू है वो इसके ऑपोजिट डायरेक्शन में जो अपने आप पैदा होगा म्यू इंटू आर का जो फ्रिक्शनल फोर्स पैदा होगा, अगर F म्यू आर से ज्यादा है तब तो आपकी ऑब्जेक्ट फॉरवर्ड डायरेक्शन में एक्सेलरेट करेगी, और अगर फोर्स की वैल्यू म्यू आर से कम है तब तो आपकी ऑब्जेक्ट वहीं की वहीं खड़ी रहेगी, चलेगी नहीं। और अगर किसी केस में फोर्स की वैल्यू म्यू आर के बराबर है तो हो सकता है कि आपकी बॉक्स कांस्टेंट वेलोसिटी से चल रही हो या फिर नहीं चल रही हो। ये दोनों केसेस पॉसिबल है इस तीसरे सिनेरियो के लिए। बट आई एम नॉट स्पेसिफाइंग एनीथिंग बिकॉज वी आर नॉट इंटरेस्टेड इन doing the complete analysis of this thing right now। All that I'm interested in right now is to draw the free body diagram FBD of this object। तो अभी अगर आप लोग इसको नहीं बना पा सकते हो तो फिर इसका मतलब है आपके कॉन्सेप्ट्स बहुत वीक है अभी भी मैकेनिक्स में। बट एनीवे आई विल नॉट वेस्ट टाइम बाय आस्किंग इंडिविजुअल पर्संस, क्योंकि आप जो बनाओगे वो मैं तो देख नहीं सकता, तो इसीलिए मैं बना देता हूं। But I assume that many of you must have had an inkling of how it has to be done। फ्री बॉडी डायग्राम के लिए सबसे पहले तो मैं जमीन को गायब कर दूंगा। That is what free means in FBD। फ्री बॉडी का मतलब बॉडी को फ्री करो बाकी के सारे झाल मेल से। तो आपने जमीन को गायब कर दिया। Now the body is independently standing। And the concept of free body diagram tells you that draw all the forces acting on the body। ये बॉडी जमीन पे कितना फोर्स लगा रही है वो आपको नहीं बनाना होता है, इस बॉडी पर कौन कौन सी एक्सटर्नल फोर्सेस हैं वो बनानी है. सो आई विल से you are pulling it with the force F, so this is an external force acting on the body, so F will be there. The ground is applying frictional force on the body, so since mu into R is the frictional force applied by the ground on the body, this will also come, ये भी free body diagram में आएगा. What about the normal reaction? इसके बारे में आप लोगों का क्या ख्याल है, ये फ्री बॉडी डायग्राम में आएगा कि नहीं आएगा? Anybody? Reaction of the floor on the body, will it be included in FBD or not?
Yes, sir.
This will be included in the free body diagram. Why? Because this is the force of ground on the body. अच्छा, mg FBD के अंदर आएगा कि नहीं आएगा?
Yes, sir.
आएगा.
ये भी आएगा. क्यों? क्योंकि mg is the force applied by the earth on the body. ये बॉडी को mg फोर्स से अर्थ खींच रहा है, तो ये भी फोर्स एक्टिंग ऑन द बॉडी है. सो हाउ मेनी फोर्सेस आर एक्टिंग ऑन द बॉडी राइट नाउ? 1 2 3 4, and all these four forces are acting on the body. So whenever you say in a situation like this, if you are simply given the task of constructing the FBD, then FBD will be like this: F mu R reaction mg. That's all. This is the end of FBD. But if somebody asks you to draw the active force diagram, now I am going to draw the active force diagram. So by this example you will come to understand what is the difference between active force diagram and a free body diagram. क्योंकि इसमें कई सारे जने कंफ्यूज हो जाते हैं और एग्जाम देने के टाइम तक भी, by the end of semester also, some people think that they are the same, कि active force diagram और free body diagram एक ही चीज है, but that is absolutely wrong. You have to understand the concept of active forces and then only you will get the concept of active force diagrams. Now the same block, the active force diagram will consist of F and mu R only. This ends the active force diagram. इसमें से मैंने रिएक्शन को हटा दिया, mg को हटा दिया. ऐसा क्यों किया? This is the active force diagram of the same problem and this is the free body diagram of the same problem. So as you can see, these are totally different. Free body diagram में 4 forces हैं और active force diagram में सिर्फ 2 ही forces हैं. So now comes the concept of active forces. Active forces are those forces which are capable of doing virtual work. वर्क भी नहीं, वर्चुअल वर्क. वर्क से, क्योंकि वर्क, नॉर्मल वर्क से अपन एक्टिव फोर्सेस को डिफाइन नहीं करते, वी आर टॉकिंग अबाउट वर्चुअल वर्क. और एक्टिव फोर्स डायग्राम्स का काम सिर्फ वर्चुअल वर्क की प्रॉब्लम में ही आता है. सो वी आर इंटरेस्टेड इन वर्चुअल वर्क. सो एक्टिव फोर्सेस आर दोस फोर्सेस व्हिच आर केपेबल ऑफ डिलीवरिंग वर्चुअल वर्क. अब मेरे को ये बताओ, क्या ये ऑब्जेक्ट जो कि जमीन पे रखी हुई है, क्या ये जमीन के अंदर जा सकती है क्या? Can this object by itself go inside the surface of Earth? It cannot go. And until and unless you apply some specific force, will this object automatically try to fly away from the Earth? No, that also is not possible. तो जब तक आपकी ऑब्जेक्ट इनकेपेबल है ऊपर उठने में और इनकेपेबल है गड्ढा खोद के खुद नीचे जाने में, तब तक इन 2 फोर्सेस का वर्क क्रिएट ही नहीं होगा. तो R and mg being vertical forces in this, and since vertical displacement is impossible for an object kept on a road or kept on a surface, so you can say that virtual work to be created for the reaction and mg force is also impossible. And since R and mg cannot create virtual work, you simply remove it from the free body diagram, and whatever remains becomes your active force diagram. अब देखो, ये ऑब्जेक्ट फ्री सरफेस पे रखी हुई है, तो इसका मतलब है कि x डायरेक्शन में इसका मोशन फ्री है. It is free to move in the x direction. And if it is free to move in the x direction, all the forces which are aligned along the x direction, which is this F and this mu r, they are capable of producing or delivering virtual work. And therefore, these forces are called as active forces. तो अब आपको क्या फ्री बॉडी डायग्राम और एक्टिव बॉडी डायग्राम और एक्टिव फोर्सेस के बारे में पूरी नॉलेज मिल गई क्या? Did you understand this concept or not? Please, somebody put your microphone on and tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, there is another topic which is called as stability of equilibrium. ठीक है? स्टेबिलिटी ऑफ इक्विलिब्रियम के बारे में आप लोगों को जो मैंने इसमें जो मटेरियल दिया है, इसको आप खुद पढ़ें और समझने की कोशिश करें. ये चीज मैं आपको क्लास में सिर्फ इतना बता के छोड़ रहा हूं कि स्टेबल इक्विलिब्रियम किसको कहते हैं. लेट अस टेक अ बाउल लाइक दिस. एक बाउल ले लिया and you take a small spherical pebble. This bowl is resting on the surface and you take a pebble inside the bowl. This is stable equilibrium. Stable क्यों है? क्योंकि अगर आप इस पेबल को उठा करके यहां पर छोड़ें, then this pebble will automatically try to return to this position. First it will go here, then come back, it will oscillate for a time, and then eventually it will come and rest at the same position. This is a stable equilibrium. Now you invert the bowl, बर्तन को उल्टा रखो, and now you place the pebble on top of the vessel. This will also be stable for a while. आपको दिखेगा कि यार ये equilibrium में तो है, so this is also in equilibrium. But if you disturb the position of the pebble and put it here, will it automatically climb up and go back to the original position? No, it will fall down. तो ये जो पोजीशन आपने ओरिजिनली इस पेबल को दे रखी थी, ये इक्विलिब्रियम में तो था, लेकिन ये इक्विलिब्रियम अनस्टेबल है, और ये वाली जो पोजीशन है ये स्टेबल है. So the concept of stable and unstable equilibrium is simply understood by the fact whether your system can go back to the original equilibrium position without any external effort on its own. In that case, it will be a stable equilibrium. Otherwise, it would be an unstable equilibrium. If it cannot automatically go back to the original position, if it disturbs on a small disturbance, if the system collapses or falls down, then it is unstable equilibrium. अब इस पेबल को और बर्तन को लेकर के न्यूट्रल इक्विलिब्रियम कैसे बनाएं, इसका बहुत सरल उदाहरण है. आप अब इस तरह का गोल वेसल मत लो, यू टेक अ फ्लैट वेसल, a flat line, and place your pebble on top of it. Now if you disturb the pebble's position and put it at some other place, it neither tries to go away and it neither tries to go back. ये ना तो इधर को चलने की कोशिश करता है, ना इधर को चलने की कोशिश करता है. आपने डिस्टर्ब करके पेबल को जहां छोड़ दिया वो वहीं बैठा रहेगा. This is the case of neutral equilibrium. So this is the difference between stable equilibrium, कि अगर वो अपनी पोजीशन पे वापस जाना चाहता है तब तो स्टेबल है, अगर वो अपनी पोजीशन से दूर जाना चाहता है तब अनस्टेबल है, और जहां छोड़ दिया वहीं बैठा रहता है तो न्यूट्रल है. So you can either explain the concept of stable, unstable and neutral equilibrium with the help of the pebble and the vessel, or the example that I have given in the notes. आप किसी भी एग्जाम्पल के थ्रू अपना कॉन्सेप्ट को एक्सप्लेन कर सकते हैं। तो ये जो आपके चीजें एडिशनल आ गई, स्टेबिलिटी ऑफ इक्विलिब्रियम, ये आपके सिलेबस में मेंशन्ड कॉन्सेप्ट है और ये आपके शॉर्ट आंसर क्वेश्चंस में आएगा। सो यू शुड नो हाउ टू राइट इट, हाउ टू ड्रॉ डायग्राम्स फॉर इट एंड हाउ टू एक्सप्लेन इट, ये आपको पता होना चाहिए। सिर्फ न्यूमेरिकल पढ़ोगे तो ये जो थियोरेटिकल पार्ट है ये आपका छूट जाएगा। एंड सिमिलरली एक्टिव फोर्सेस, एक्टिव फोर्स डायग्राम्स, इसका कॉन्सेप्ट आपको अपने शब्दों में समझाना आना चाहिए। प्रिंसिपल ऑफ वर्चुअल वर्क, मैंने आपको एक छोटा सा डेरिवेशन भी करा दिया आज, वो भी आना चाहिए। प्रिंसिपल ऑफ वर्चुअल वर्क का स्टेटमेंट भी आना चाहिए। वर्चुअल वर्क क्या है ये आना चाहिए। यू शुड नो द कॉन्सेप्ट ऑफ वर्चुअल डिस्प्लेसमेंट। तो आज अपन ने जितनी पढ़ाई की वो एक तरह से इंट्रोडक्शन हुआ। नाउ नेक्स्ट क्लास ऑनवर्ड्स वी विल एक्चुअली स्टार्ट सॉल्विंग प्रॉब्लम्स विद द हेल्प ऑफ द कॉन्सेप्ट ऑफ वर्चुअल वर्क। ठीक है, तो आज के लिए अपन यहाँ पर स्टॉप करते हैं। बट एज आई टोल्ड यू, आप लोग अभी क्लास छोड़ के ना जाएं, जल्दी ना करें। लेट मी टेक द अटेंडेंस एंड स्टिल इन ऑर्डर टू कंफर्म दैट नोबडी इज मिस्ड आउट,
सर
मैं एक बार वर्बली आपको नाम भी बोल दूंगा।
सर
हाँ
सर एक डाउट है।
हाँ पूछो।
सर आपने कहा था कि सर नॉर्मल फोर्स रियल फोर्स होता है क्या?
कौन सा?
नॉर्मल फोर्स,
नॉर्मल रिएक्शन।
नॉर्मल फोर्स रियल फोर्स होता है क्या सर?
नहीं, मेरे को क्लियर नहीं हुआ आप क्या कह रहे हो।
सर जैसा आपने कहा था कि वर्चुअल वर्क जब होता है तब रियल फोर्सेस लगते हैं।
फोर्सेस तो सारी रियल होंगी, फोर्सेस कभी भी वर्चुअल नहीं होती है, सिर्फ डिस्प्लेसमेंट ही
तो
वर्चुअल
सर
होती है।
फिर नॉर्मल से अपन वर्चुअल वर्क क्यों नहीं निकाल सकते?
क्योंकि आपका उस डायरेक्शन में डिस्प्लेसमेंट की कोई गुंजाइश ही नहीं है। नॉर्मल रिएक्शन के
तो सर
डायरेक्शन में आप अगर उस ऑब्जेक्ट को उठा रहे हो तब तो वो आपका एक्टिव फोर्स बन जाएगा। यस, देन इट विल बिकम एन एक्टिव फोर्स। लेकिन अगर आपने पहले ही ये डिक्लेयर कर दिया कि मैं ऑब्जेक्ट को उठाने की चेष्टा ही नहीं करूंगा, उस दिशा में कोई चेष्टा नहीं हो रही है मेरी, तो फिर आपका वर्टिकल डायरेक्शन ही बैन हो गए। और आप ये कह सकते हो कि वर्चुअल डिस्प्लेसमेंट जब वर्टिकल डायरेक्शन में होगी नहीं तो फिर वर्टिकल डायरेक्शन में जितनी भी फोर्सेस हैं वो वर्चुअल वर्क करेगी नहीं।
ठीक है सर, थैंक यू सर।
अच्छा एक सेकेंड, आप लोग अभी जाए नहीं, लेट मी जस्ट रीड आउट योर नेम्स, ताकि कोई लड़का अगर छूट जाता है तो वो अपना मेरे को कंफर्म करा दे एक बार अभी हाथों हाथ। ठीक है, ये देखो आपकी अटेंडेंस ये आ रही है। अमन शर्मा, एक ही जने का नाम आया है क्या? अमन शर्मा दोनों प्रेजेंट है क्या?
Say 23.
22 and 23 both are present.
Both are present.
ठीक है, क्रिस्टी, दीपू, भानु कृष्ण, आशीष कुमार, भास्कर, चेतन गुर्जर, अक्षय सिंह।
Sir, Aman Sharma,
कौन
22.
है? नहीं, आप पहले, मैं जो नाम पढ़ रहा हूं आप सिर्फ सुन लीजिए। आपका नाम अगर आता है तब तो ठीक है, और नहीं आता तो मेरे को नाम बताइए। ठीक है,
22.
क्रिस्टी, दीपू, भानु कृष्ण, आशीष, भास्कर, चेतन गुर्जर, अक्षय सिंह, अनुज त्रिपाठी, आदित्य राज, दीपक मीना, अतुल जैन, आयुष वैष्णव, अक्षत शर्मा, अजय प्रताप सिंह, अमित पारीक, अक्षांश खांडेकर, अखिल शर्मा, अजय पाल सिंह, अमन आदित्य, अभिषेक तिवारी, अक्षित शर्मा, अभय राज, अक्षत सिंह, अजय कुमार बुरी, अभिषेक पांडे, अभिषेक कुमार कुशवाहा, अक्षित कुमार सेन, अमन बहेती, अमनदीप सिंह संधू, अमन खान, आमिर खान, अमित दुबे, अमित माथुर, अनिरुद्ध जांगेड़, अंकित शर्मा, अंकित यादव, अनिरुद्ध सिंह शेखावत, अनुराग दाधीच, आर्यन सोनी, अश्विन सिंह, अविरल कुमार, भानु प्रताप सिंह चौहान, भरत कुमार, चैतन्य, चिन्मय जैन, चित्रांश, दर्शन जैन एंड दीपक कुमार यादव। इनमें किसी का नहीं नाम आया हो तो बता दो, और अगर आपका नाम आ गया है देन यू कैन लीव एंड हैव द रेस्ट ऑफ योर डे।
Okay, sir.
Thank you, sir.
Okay. Bye bye.